on page 5, we do have a lot of fractions. Okay, so what I'm going to throw out here, you guys, as we're looking at page 5, and we see all these fractions, is there something I could multiply every single thing by to get rid of that fractions are annoying. Fractions are annoying. What could I multiply just this by to get rid of its fraction? If I multiplied this by a, what would I get? Wouldn't I get like 5a over a? Okay, and if I did that, we'd get 5. Is my fraction gone? We love that, right? We don't like fractions, but I can't just multiply this one by a. That's like me saying, hey, Graham, here's 200 extra credit points. Everyone else is going to be pretty ticked if I didn't give it to everyone else. I know you would be. So I can't just multiply 5 over a by a. So I want to multiply this one by a, but what do I have to do to every single thing? Multiply them all by a. So let's go ahead and write that down. You might not write it that way. You might write it instead of this is what we started with. And you might say, all right, I don't want to write it like that. I might just say I need to multiply everything by a, and you might show it that way. Either way, everything's got to get an a. As long as I give you all 200 points, you're all happy. So a times a would get me what here? A squared minus 5a over a. What's going to happen there? 5 equals 4a. Woo, does that look like a quadratic that we dealt with yesterday? Let's get it set equal to 0. We got this. What would we do to set this equal to 0? Yeah, we got to move the 4a over. But you know what we do like? That it's a 1a squared. Guys, are we tooting or o-tooting? We are actually tooting. Just tooting. Yep. What are we multiplying together to be? I love tooting. I'm glad. That's so smart. Right? I did, Dar. Oh my gosh, you did. Thanks, Dar. Appreciate you. -5 times 1 is at -5. -5 plus 1 is at -4. Yeah. So we got a plus minus 5, and then a plus 1. What are my two values for a? Agreed. I'm going to teach you the best way to check this, people. I'm going to teach you the best way. This problem, actually this one we could just do by hand. I'll save the best way for down here. If a is 5, what would this turn into if a is 5? Yeah, what's 5 minus 1? 4. Is that what it's supposed to be? Yeah. Great. What about a -1? What's -5 over -1? 5. Is -1 plus 5, 4? Yeah, so these are both good answers. Okay, so again, we've got fractions. We don't have to solve these all the same way. Anyone have an idea, since I've got one fraction equals another fraction, how... Yeah! You guys, when we've got one fraction equals another fraction, you get to always just cross multiply. I love that. What would 1 times 2m squared get me? Yeah? What about m times am, like m and am? Thank you. Minus 34m. Love it. Dar, I love that you love to toot. Okay? JK, JK, JK. Here's my question. We need to get this. Oh, I thought that I had. Never mind, you guys. I don't even have. I thought I had a quadratic. I don't. Because these can get combined. So you guys, let's move that 1m squared over by subtract. Yeah. Minus 1m squared would leave me with 1m squared. Can I just say m squared? Can I add my 34m over? What are we going to factor out now? An m. What's left? I got m plus 34. Has anyone watched Miracle on 34th Street? He says, okay. You guys, let's solve this. What would m equal? M would equal 0 and you got it. Now, we got to check this. Here's what I'm going to suggest. I'm going to teach you the coolest little trick. Grab your calculators. Grab your calculators. Let's make our lives easier. And in order to check this, this is going to be easier if I have this on one. Nah, never mind. You guys, if I plug in a 0 here, am I allowed to divide by 0? No. Do you guys agree m can't be 0 because I can't do 1 divided by 0. 0's out. I don't like it. Boom. You guys, let's go plug in negative 34 here. So I'm going to go ahead and say, all right, we've got negative 34 minus 34 over 2 times negative 34 squared. What do I need to see if that's equal to? 1 over negative 34. Did I get the exact same thing? So I feel good about that. Why did I take this guy out? Because I can't divide by 0. 0 is not going to work. Okay. Okay. Here's the tough one, you guys. I want you to act like this does not exist. I want you to act like this is all we see. What would you multiply this by to get rid of that denominator? Y plus 2, right? If I multiplied this by y plus 2, then my denominator would cancel, right? But I can't just do that. I need to do that to everything, right? So I need to multiply this one and this one and this one because if I just gave Graham the 200 extra credit points, everyone else would be ticked. But now I want you to think about this. I'm going to use my hands instead. What does this guy need to be multiplied by to get rid of his denominator? Just a y. He has to be multiplied by just a y. Is that going to work with this y? No, this is some y plus 2. So whatever y's value is, you're going to add 2 to it. It's not going to match this guy. So this also needs a y here. If I gave just Abby Kale 200 extra credit points, everyone else would be ticked. So everything else needs a y as well. That's where it gets a little, I think that's hard, okay? Because you can't think that this y is going to cancel out with that one. This is one quantity that's going to cancel out that denominator. This is another that's going to cancel out his. Do we have something that's going to cancel out with this one? Yeah, that one is already taken care of. So you guys, as we picture this, we're going to do this one step at a time. What's going to happen with this 2y plus 2 and this y plus 2? Do you agree that they're going to cancel there? And I would be left with 2y. It's just going to do it. You got it. What's going to cancel out with this y? Wow, the y.
I believe you're left with 3y plus 6.
Yes, I love that you already distributed that too, Graham Wilstog. Lastly, what's going to cancel out with this y plus 2? That y plus 2. And I'm left with negative. Perfect. Now, you guys, Dario, remember how you said toot is just so much easier. It's a good little method. Toot only works when it's positive 1y squared. So do you want to move all this stuff to the right or do you want to move that guy to the left? Yeah, because then it would turn it into a positive y squared. So you guys, I'm going to add y squared to both sides. So I've got y squared plus how many y's? Plus 6 equals 0. And now Dario is so happy because she gets to go T-O-O-T. Dario, you know me. I just really like to play it up when kids say that they like something. So I apologize. You said it, and now I really... It's because I appreciate it so much. You guys, what are two numbers that multiply to be 6, add to be 5? Oh, we finally got a 3 and a 2. 3 times 2 is 6. 3 plus 2 is... Yeah, me too.
I was doing 3 times 2.
He says I'm perfect. You guys, what's my y going to equal? Appreciate you. Now, I'm going to help you guys check this. So actually, again, this we might not need it for this one. How about, oh no, what happened to my answer? What were my two answers? Y equals negative 3 and negative 2?
Yes,
Whew. You guys, what happens if I put a negative 2 in here?
Okay.
Am I allowed to divide by 0?
Hold the phone.
No.
Hold the phone.
What's up?
Why are they negative 3 and negative 2?
Because when I put them in this, y plus 3, y plus 2 equals 0, they're always going to be opposite. Love, you agree that we can't make it negative 2, though, because negative 2 plus 2 would get me a 0 in the denominator. Could it be negative 3? Yes. Yes, it can.
Like I would rather like a 90.
You guys, something that I want to just show you as an option to check this, which I think is pretty cool. You guys, I want everyone to do negative 3, stow, X, enter. That stow button is right here. Boop.
Oh, not this.
No, it's awesome. It's such a helper. I promise it's such a helper. Stow is right there. You see the stow? Just hit stow. And then X, and then enter. And then you guys, I want you to type in this problem. I want you to type in alpha y equals 2 over, instead of y plus 2, I'm just going to do x plus 2 because that button is so much easier. 2 over x plus 2 plus 3 over x. That's going to equal something. And did you all get -3? And we don't know if that's what it's supposed to equal. Let's go type in this side and see if that's what we get for that side. Alpha y equals, and we got a negative x over x plus 2. Isn't that just kind of a nice way to see, like, without checking it by hand? Yeah. The only reason that worked is because we stored this answer in for our variable before we typed in that function. Ha, that's a great question. How do you unstow it? We can't. But it's never going to hurt us for anything. It's not going to hurt at all. When you graph, when you do like a y equals, it doesn't affect that x.
Okay.
It doesn't hurt anything, okay?
I have a question.
Number 19 on the next page, you guys, what if we just had this? What do I need to multiply everything by to get rid of a 2q plus 3? A 2q plus 3. So you guys, do you like it on, I feel like it does help when you show it on each one. 2q plus 3, but everything needs a 2q plus 3. And everything needs a 2q plus 3 because Graham is not the only one getting 200 bonus points, okay? But you guys, what happens when I look at this one? I need a 2q minus 3 to cancel out the middle one, don't I? So I'm going to do a 2q minus 3 over here. And 2q minus 3 over there. And I hear you. She's like, dude, this is miserable. You guys, what would I need to multiply?
Yeah.
Question. What do I need to multiply this by to get rid of its denominator of 1? Do I really need to say that we're multiplying things by 1? Is that going to change anything? No. Okay. So, you guys, let's just focus on the first one. What's going to cancel out here?
2q plus 3.
Yeah, I got a 2q plus 3 on the bottom and the top. So I'm going to do this. What is left
Oh my gosh.
when I do that?
Okay, go ahead, Daria.
4q squared. She's allowed to do it. Minus 6q. I apologize. My q's are very ugly.
Oh, would you like me to do the next one?
Sure.
Oh, thank you. So, it's going to be also 4q.
So this is very scary. Be careful about this minus.
Oh, -4q.
Yeah, and then this is the hardest part. Is it plus 6q or minus 6q?
Oh my days! No, never mind. Just don't ever call me again.
No. Do you agree if we really have this looking at us, Mr. Beck? Beck, you agree we really have this staring at us.
I saw that. I see it now.
So you agree we did have minus 4q squared, then what are we going to have, buddy?
I'm a little, you're gonna have a -6q.
Negative 6q? Whew.
That's what I said.
Thank you. I missed it.
No, you didn't.
Here we go. No, that's a good call. Don't forget, this negative 2q is over just 1. So this is really just a minus 2q there. That got to go with that. And we're multiplying it by that of a 2q plus 3. So when we distribute that, boom, boom, we would have that minus. Yeah, that's a very hard thing. We often forget to distribute that minus. You guys, what are we going to have over here?
I like 2q plus.
4q squared.
Oh, never mind. I don't know.
Close. What's this going to get me?
It's gonna get -6q.
Yes, what's this going to get me? Oh, yeah. Yeah. Plus 6q. Sorry, I thought that they were both minuses.
Is that the equal sign?
Right here? Yep.
Thank you. Thank you.
And then, as Dice, you said, we have -9. Dicey just skipped a step. Are we allowed to just say minus 6q and plus 6q is 0? Yes. Absolutely. Whoa, this is nasty. Is anything going to cancel out? What happens with this 4q minus this 4q squared? Yeah, those cancel out. We love that. How many 6q's would I have over here? Negative 12q's. We got equals 4q squared minus 9. Where do I want to move stuff? To the left with the negative 12q or to the right? Yeah, you guys, let's go to the right because I do like having a positive q squared. So we'd have 4q squared. Then what? Yes. Toot or oh toot? Oh toot. I appreciate you. Again, the positivity just makes me flourish. Here we go. What multiplies to be negative 36 and adds to be 12? But the negatives are messing us up, aren't they? Because how would we multiply to get a negative 36, but add to get a positive 12? Not quite, because the negatives.
Come on, guys. Lock in. You might have to use the one.
You guys gotta dial.
4 and 9?
Let's go.
It's not looking like it can be done.
Yes, it is.
It's not looking like it.
3 times what gets me 36? 3 times 12.
Oh, indeed.
Oh, indeed. Oh, wait.
It doesn't work.
It's not looking like it can be done.
You guys, you're right. Shoot, this is prime. Sorry, really thought that we could factor that. So when it's prime, what do we got to use? Yeah, x equals negative b plus or minus square root b squared minus 4ac all over 2a. Sorry, Graham, you read enormous though. Here we go. You guys, what is my negative b here? Yeah, so we got x is negative 12 plus square root. What is b squared?
Holy moly. We're squeezing.
144 minus 4 times what times what? 4 times, oh, thank you. 4 times 4 times negative 9 all over 2a, which is 8. Okay, Graham Wilson, I promise. If you just got that written down, all I'm going to have you write personally is just going to be the answer because you don't have any more room. You guys, let's go get what's underneath my square root. What is 144 minus 4 times negative 9? 288. 288, you guys. We've got negative 12 plus or minus the square root of 288 over 8.
That's real talk right there.
Those are going to be my 2 roots. You guys, I'm actually fine with us simplifying right there. Okay, no, we can't simplify these two, 12 and 8, with a 4 because this coefficient is a 1, and he doesn't have that in common. I could break down the square root. I just don't really want to do that right now. You know what I'm saying? Yeah, ooh, 144 does go into it. Oh, snap, now I'm enticed. You guys, don't you agree? It's plus or minus square root of 144. 144 times 2 is 288, right? What's the square root of 144? 12. What would I have left under my root? Just a 2. Wouldn't it be just a 2? Because the square root of 144 is the 12. I just have that little guy. Now, can I simplify 8, 12, and 12 have what in common? Yeah, if I divide each of these by a 4, what would be my final answer? I know. Negative 3 plus or minus 12 divided by 4 is 3. Leave the root all over. Done. Now, you guys, if you stopped at this one, I'm okay with it. I'm okay if you stop here.
Okay.
Truly. You guys, what I want to do on 20, I actually don't even want to do all of 20. I just want to do the setup. See if we can figure out what we would multiply by. We do not need to solve this whole question. My question is, just focus on this. What do we need to multiply everything by to get rid of that denominator?
Answer this one, please.
What is it, everybody?
Okay, so 3M.
3M.
4M.
No. Chill. Everyone needs a 3M.
Okay.
Now, does that 3M take care of this guy's 3M? Ooh, does that 3M take care of my 4M?
No.
Does it take care of part of it?
Yes.
Could these M's cancel out?
Yes.
Yes, so I don't need an extra M because the M is already taken care of. What would I need to multiply by to get rid of that 4?
5.
Another 4, wouldn't I? I'd need to multiply everything by another 4. Boom, boom, boom.
Okay, I like this.
So, as we simplify that, I just want to do the first step. We don't need to take it any further. Do you agree my 3M's would cancel?
Yes.
So we got doom, boom, what's left? 4. And over here, my 3M's cancel. What is going to be left? Careful. Wouldn't it be 24M?
Yeah.
24M minus...
I'm just confused where we got the
Minus 36.
Good question, Graham. So right here, do you agree this M that we already had multiplying by it would cancel out with this M?
3 of them.
But
right?
yeah, right? That M is going to cancel out with that M, and that M. But what do I need to multiply to get rid of a 4? 4 over 4 would cancel out that guy. Yeah?
Oh, then you're going to multiply all those by 3?
Yeah.
Okay.
Yeah, exactly. Yeah. Let's take a peek over here. Because now, do you agree this M is going to be canceled out with that M? This 4 is going to be canceled out with that 4. And then to your point, I do have just a 3 to multiply through. That would leave me with a 9M minus 9. What would I multiply this guy by to get rid of this denominator?
I know. Maybe n plus 1.
Agreed. This one needs an n plus 1, therefore they all need an n plus 1. What am I going to multiply this one by?
N plus 1 minus 2?
Well, we already have an n plus 1, right? We just need to add the n minus 2.
Yep, okay.
What about this guy's denominator? What's his denominator? It's just 1. We don't need it. We could multiply everything, but to Sam's point, we could multiply everything by 1. It's just not going to change everything. So, I want to just do the write-up what the setup would be, and then we don't need to solve this one. What would I get here? Oh, sorry. Or actually, I'm even fine with us just writing n plus 1, n minus 2. That would be on the left side. What would I get here? What's going to cancel out here?
The n plus 1, the n plus 1.
Yes, the n plus 1, the n plus 1. What would I have left?
Probably like an n squared.
And I'm actually cool with it, writing it even not distributed. We'd be left with an n plus 6 times a...
N minus.
Yes, equals... Oops, I put a... Thank you, Dar. And then what would I have left?
The n plus 1 times 4.
Yeah, 4 times an n plus 1, and you would distribute to solve it, but I'm more interested in can we get that first step? Okay. Does this one look gross? Right? Looks terrible, but you guys, I know I'm pretty evil, but I'm not that evil. We can toot this. What do we hope it breaks into? I'm hoping it breaks into that. Is it? Let's think. Is it? Are we going to multiply to be negative 4, add to be 3? What are my two numbers that multiply to be negative 4, add to be 3? X, 4 times negative 1 is negative 3. 4 minus 1 is 3. So you guys, what a relief. Can you keep those away back?
Yeah.
So what are we going to multiply this guy by to get rid of my denominator? What does he need?
Are we using n's or what?
This one's an x plus 4, isn't it?
Yeah.
Oh, geez, why did I put x's? Thanks, Graham. I have no idea. We need an x plus 4 on all of these. I think you're going to like this one, actually. This problem winds up being not bad at all. What do we need to just to cancel out this guy?
X minus 1.
An x minus 1 on all of them.
And then we're taking care of the last one.
Yes, so good. So, when I distribute this, when I just focus on this, do you agree my x plus 4s, they cancel?
Yes.
What's left?
X minus squared minus
Say that again, Curve Dog.
x squared minus a.
Yes. You okay with that, Lushy?
Yeah.
Okay. Now, be careful, because look what I'm staring at right here.
Negative.
Yeah, mm-hmm.
I would so forgot.
Right? These are going to cancel. What's going to be left when I distribute this?
Do it. It's going to be
Negative 2x
Minus.
minus 8. Because of that. You okay with that, Lushy? Okay.
I was going to say plus negative.
Oh, perfect. You guys, this is the best.
You get 20.
Yes, because my x plus 4s, this guy cancels there. This guy cancels there. We're left with 20. You guys, we got x squared. How many x's do we have over here?
Probably like negative 3.
Minus 3x's, then what? Minus, if I set this equal to 0. Oh, wouldn't it be minus 32?
Yeah. Have a bit of a brain math.
Minus 20.
No.
Oh, wait, wow. Woo! I had a bit of a brain lapse, too. You guys, are we tooting or O-tooting? Okay, all right. What multiplies to be negative 28 adds to be negative 3. Multiplies to be 28. Negative 7 times 4 is negative 28. Negative 7 plus 4 is negative 3. You guys, we got x minus 7. X plus 4. What are my x's going to equal? Yes. Why can it not be negative 4? She's saying, because look at this denominator up here. She's saying, don't I have a denominator of positive 4? If I put a negative 4 in there, wouldn't that be something over 0? Can't have it.
Should we use the stone?